And you don't mind if I record this, right?
No, I don't mind.
Yeah. Okay. So what would make this the most productive so we get
Thanks.
what we need out of this call?
Yes, sir. So I've got a Google Doc. Let me share that with you. Eventually,
Mm-hmm.
this can become a locally hosted document at OSP site or something like that if it's valuable.
Are you
Um,
sharing that right now?
yeah, it's coming in the chat.
Okay.
Oh, yeah. Uh, so we can talk about a couple of these different things um, that we have been discussing, but the
Mm-hmm.
main discussion I think is about how can we collaborate to make the agro ecotech a viable path if that's desired.
Yeah.
And then what could it look like to establish local building of seed eco homes here in Alabama? Um, I did some deep digging. So I really thought that a very profitable um, option was to build accessory dwelling units
Yeah.
on sites here in town, because often they have football games where they have people coming in from out of town to the football
Mm-hmm.
games looking for seasonal or short term rentals. But what I found is that there are extremely inhospitable regulations around that, which is probably for the best. Uh, but basically, they won't allow people to do that. Um,
So okay, given
so
that it's so difficult, do you think that's still an impact point to pursue right now, or does it
I think
deprioritize it?
that it is kind of a deprioritized. I mean, one of those things I was thinking about was, so for example, I have a local builder who builds custom cabins. And so in theory, we could contract like a number, like 10 cabins or 15 cabins with him, if we really wanted to do that. But we would have to figure out a market for it. And so I think the market where I am is pretty inhospitable for that.
Mm-hmm.
Um, I was thinking if we wanted to change the form factor to be something like the micro house,
Mm-hmm.
then maybe we're looking at something that could be mass produced as a living unit, but also produced as uh, like the mobile processing center or the
Yeah.
mobile. Uh, it could kind of double as a laboratory or a living space depending on
Yeah.
what the use is.
In-house, we're pursuing 10 by 12
And
modules. Okay, so 10 by
10 by
12 in
12.
size, which you can stack up to 4 stories to make basically a village, whole village, apartment complex or whatever. We're going to plan on using that for the student housing here. So that's definitely in development. And so you've got core building modules, bathroom units, kitchen units, other modules, roof modules, and stair modules, and then canopies and decks. And it's like really plug and play. So for vertically, we can use a telehandler to lift them up, just like kind of like shipping containers. Hmm.
Right. Exactly. So is that designed the 10 by 12?
So that 10 by 12 design doesn't exist yet, but we know we can use
Oh,
our building system. So we're planning on just using 8 foot tall modules, and part unique part count is one for structure lumber,
sure.
just 2 by 6, because that could work for the floor and ceiling to get you vertical stacking still. Hmm.
Oh, that's great. Yeah, that's awesome. And the only reason I ask is because then I'm sure I really want to build, a half dozen units on my premises to host. Folks are already asking to come and visit, and I don't have anywhere to put them.
Hmm.
Um, so, I want to do that right away.
Yeah,
So
yeah,
that's
yeah.
great.
Okay. As far as any opportunities for so the way we're going to frame it's a future builder enterprise formation track. 6 months, 10K, 100K, 10x. So 6 months of training, just immersion. You learn all the modules, and then in 6 months you set up your own business. We can buy the work from you to the tune of 100K per year. So basically, you can set yourself up in business. That's the track. It's called the Future Builder Enterprise Formation track. So very intense for people who want to do that, who have the confidence to do that. But I'm wondering if you see any people in your area who'd be into that, who've got enough maturity or drive to actually do a program like that. Because it's not super entry level. It's like you really want to be able to do that, and if you're pursuing financial independence.
Yeah, especially because it is the notion of workforce development here in rural
Hmm.
Alabama. There's not a lot of options for employment because the major industries are leaving for more favorable conditions, and so being able
Why
to
is that? Like
establish something.
industries leaving for? Tell me more.
So in Alabama, there are three major industries. One is steel, one is lumber, one is like as auto and aircraft manufacturing. Um, and all three of those are moving away from South and Central Alabama to coastal regions, and then again away from coastal regions to other places in the U.S. where regulations and economic conditions and labor are more abundant, but
Hmm.
also overseas. So there are whole like for example, Birmingham, Alabama is a well known name, but it was established because of steel processing, and it doesn't do that anymore.
Hmm.
And so most of the buildings in Birmingham are repurposed steel industry buildings.
Yeah.
Um,
Yeah.
and whole towns are now dealing with the shift in labor model, a shift in tariffs,
Hmm.
shift in economic conditions overseas for manufacturing and all that.
Hmm. Hmm. Yeah. Okay.
There are unused, untapped workforce here. I can also, to adding to that, I can apply for grants to establish not a sister program, but a leg of the programs here to bring in, community college students, unemployed graduates to do this program and build these homes.
Hmm. Yeah. Are you working on a specific grant right now on that?
Yeah. Well, so I'm working with a guy who's got some grant, and I'm trying to figure out what it's going to take to build a maker's. Because he's doing, we talked about it, he's doing the Prius, converting the Prius into a mobile um, emergency vehicle where it's basically a generator,
Hmm.
Um, and so he's built a shop to modify Prius vehicles into essentially small emergency response units that can go when there's a storm or a disaster and provide energy and a heated chamber for sleeping in the cabin of the car. And so basically being this mobile emergency unit. I
Hmm.
want to build a sister or a breakout of his makerspace in my space for the construction side of that, which is basically so much of Alabama's housing is crumbling. And there are so many nonprofits looking to rebuild existing houses. Oh, but to build modular homes, even on mobile chassis,
Hmm.
like mobile homes,
Hmm.
would be a really excellent way to give short-term relief when disasters. And right now, we've got this freeze coming down south, and people are going to die. And infrastructure is going to be impacted. And being able to develop these, like you said, quickly, year after year, in a consistent way, it's something that could alleviate the infrastructure strain on the housing market here.
Yep.
So that is to say, I am applying for grants. It's really tough for me to win grants because I don't have an established financial history. So I'm kind of trying to partner with other folks in Alabama who have grants.
Hmm. Hmm. Yeah. Yeah. Um, do you want to continue talking, or should we talk about the? Just start thinking what we should dive into. Do you want to continue on your
I
doc,
think
or?
yeah. Let's keep that on the back burner. I think what you can think about that would be helpful, and I'll also be looking at basically the profile of seed eco home designs that are available. What are the market conditions here? I know I want to reproduce several modules. I mean, for example, I want to move my parents down here from Texas, and I want a module for them,
Hmm.
um, and so forth. So I think there are some practical steps to take forward there. We can explore further. The next thing I want to look at, maybe this is a share screen I'll do.
Okay.
This is also publicly available, what I'm going to share, but it may be helpful to
Hmm.
have share screen. Okay. So I'm developing this. You're on the email thread with an interested party who's asking about the drone
Hmm.
design. And so what I realized is a big part of it is there's so siloed are the resources you need to do land management.
Hmm.
So there's one portion of this is heavy equipment. one portion of this is sensing. So that's drones plus GPS,
Yeah.
RTK, and all that kind of stuff.
Mm-hmm.
And then one part of it is planning and data integration. And so what I was thinking is let's start to consolidate these modules in a way that makes sense for 21st century technology.
Yeah.
Um, so for example, in this ground control site, so my idea is this could actually be a commercial platform that competes with like ArcGIS or some of these more commercial. It's open source by the way. It's currently all the software is on GitHub and it's available right now. But so you try it, and what it gives you is the opportunity to do mapping and survey online in a browser environment. So, for example, let me pull up my property is right. Where am I? And I can switch to satellite.
You're feeding that into your website right there.
Yeah,
Mm-hmm.
yeah. This is live. You could go check this out if you want. You could check,
Is that from a Google map or
and
from what's the source?
so this is open. This is an open mapping database. So there's some groups that maintain open
Okay.
maps.
Okay.
Yeah. So using an API, I'm pinging it there. This isn't Google though. This is a different thing.
When you do this, are you using
Yeah.
AI to generate code for your website, or are you just doing it manually?
Some portion of it, but it's kind of tough. It's just not as it's not really there yet. But yeah, some portion. For example, like all these interfaces where you see all the buttons look the same.
Yeah.
Like I'm using AI to make the buttons. There's no reason for me to make buttons.
Yeah.
Yeah. So the part of it is identifying that your plot. I'm embarrassed. I'm having trouble finding myself right now. Let's see. I'm like the. Here we go. Okay. So by the way, just so you know, this is my plot. Is this 40 acres right here? And so you asked about do we have timber? It's almost all timber.
Holy cow! You
I've cleared
basically
it.
40 acres of pure forest. Okay.
Yeah. And so I cut out 1 acre right here. It's not up to date because the satellite's hasn't scanned it yet. But I carved out 1 acre right here and put a cabin there, which is where I live.
Mm-hmm.
But that's what we've got. And so the idea is you can define boundaries in here. So you can click, and draw your boundaries here. And what you can do is jump to, okay, this side is a little less developed, but it's an example of what we talked about with the visual odometry or, orthographic reconstruction. So using a series of like 30 images taken from a drone, and they're here. So it's like, they're not like super high fidelity images,
Mm-hmm.
And I didn't take these images. I found an open data set.
Wait, that's your
But
stuff
basically,
that was cut from your place?
no, not from my place. I just found some open. The drone, I do have some drone videos of my place, but the weather's been too bad for me to go back and get a good, without risking hitting the trees or getting rained on or getting mud on it. But I intend to do that soon.
Mm-hmm.
But essentially, by taking these 30 pictures, were used to reconstruct this plot here.
Yeah.
And what I'm working on is I'm going to be able to go in and like select parts of this and carve out parts of this. Like I can highlight, click and drag and say, remove this. Or I can click a structure like the mobile chicken processing unit and then click where I want it to go. And then my robotic platform, multiple skid steers become aware of where I want that to move and go and, hitch onto my mobile processing center and move it where I want it. So it becomes this fully integrated farm control platform.
That'll be running off a powerful CPU, or would be like on your cell phone, or?
So it could be done. Some of it could be done locally. So my idea was what I would do. You would do your mapping and planning here. Press download. So you download like a G code, like you would for a 3D printer.
Yeah.
And then upload, USB and upload that G code into your skid steer, and the skid steer figures it out from there.
Yeah.
Some local computation or some, but in terms of being able to do it, like it could also all be done online, but then it would just get more expensive.
Yeah.
But yeah, it could be done. Yeah, either way could be done.
Yeah.
So that's kind of the vision for what I've got here. Let me stop sharing. So that's the ground control, and so my hope is integrating that with the drone development, and the skid steer development, then we kind of really take off in terms of, like I said, the integrated control environment.
Well, let's. I mean, I don't know. Do you want to just dive into the skits? Like, do you want to talk more about vision planning, or more like? I mean, we can go right and let's talk about how we're going to integrate the skid steer. So assume we've got a mechanical system with hydraulics and and 4 solenoids, or 6 or 8 solenoids, and how we controlling that. Do you want to dive into just looking at the components of that process with the RTK
Yeah,
GPS?
we can do that. Yeah.
Okay.
Is that something you want to share, or do you
No,
want
I don't have
me to
anything to
start a
share,
doc
but
for him?
let's. Why don't we start? Let's do a slides. Let me start a slides, and you
Okay.
want to start mapping it out. What it requires?
Yes.
Okay. Did you cover everything you had in your doc, pretty much, or
Yeah, I
just
mean, so the other big part of it was I've got some design requirements for the mobile chicken processing. I don't know if you know this, but for processing chicken, you're exempt under 1,000 chicken volume. You're exempt from inspections.
mm-hmm, mm-hmm.
So you can process those. And we talk about like, do we need USDA or FDA approvals? Like, no, you're good to go. We can develop a mobile chicken processing center with essentially no permitting requirements.
Uh-huh. Now, is that statewide for you or nationwide?
It's for you for Missouri.
Oh, for
I got to
Missouri.
double check for me.
Okay.
Yeah,
Oh, cool, cool,
yeah.
cool. Okay, so 1,000, we're good. Yeah, let those chickens roam. Okay. Um, so let me just do a doc real quick. Just do a quick. I'll seed it, and then we can work on it. Let's start mapping out the. Yeah, I mean, let's start mapping out the system. Gonna make a copy here. Make a copy. Okay. Do you have a little logo for like? We can put this at the bottom. Can you paste the?
Oh, sure. Yeah, I'll send it to you. Thank
Well,
you.
you can. If this is shared, so right here, let me share that. Anyone with
Oh,
a
great.
link
Okay.
can actually edit.
Thank you.
So if you. Okay, so go into this doc. Let me paste it in the chat. Okay, right in there. Um, so let's just start it. Put your logo in there. I'll put the OSC stuff. Okay, we got FreeCAD, open source ecology, and open hardware. Skid steer. Okay, that's the logo you're using these days.
Yeah.
Cool.
Yeah.
Mm-hmm. Okay, so the controller would be controlling. So for motion control, you've got four solenoids running four independent wheels. So you got the RTK GPS. Above that layer, we're gonna map with the drone mapping, um, right? So that's how. And you've done that. So what you just showed was topographic maps. And the process for doing that is, what are you using exactly? What's the tool set there?
Called Open Drone Map, Open
Okay.
Drone Mapping. So one word as a like ODM or something.
Mm-hmm. And the hardware is you using a commercial drone with what software on it?
I'm using a commercial drone, so essentially, it's right now the process is offline. So you can take any video, drone video, and then convert it to a topographical map.
Uh
So
huh.
it's agnostic of a hardware, but I'm intending to constrain that. So maybe in some way that's like uh, adapting the drone Korea design or something like that to constrain the design variables there.
Yeah, I talked to Lot of Drone Korea today. Actually, you can see the video online. So
I
he's
saw it. I
open.
took the
Yeah,
video.
have you seen it?
Yeah, I watched it.
Yeah, yeah. So yeah, man. He's willing to do that workshop with us. Basically, transfer the tech and including the open source gimbal development. But yeah, I mean, is that how you'd see it going? Like right now, maybe just get this from him as soon as we can, and then start integrating all in the open tool chain.
Yes, I think you know I've been discussing with, as I mentioned, I got some folks I'm working with on on the drone design questions,
Mm-hmm.
and I discovered there are a shit ton of open source drones. So there is no shortage of redesign that we can do. Like all of the design questions we're talking about have already been solved. Like I'm sure there is an open source drone camera gimbal. Like we'll find it.
Okay.
Um, so I'm not concerned with the shortage of design resources. I'm sure it's already done.
Okay. Who are you talking to as far as the developers there?
I'm talking to a friend of mine. I met him. Actually, I met him on the plane like 2 weeks ago. We were flying back from
Hmm.
Texas. But yeah, I'll keep him anonymous just for. He's not really in the open source world. He's just a friend of mine.
Okay.
But he
Okay.
works for one of these defense contractors.
Now the stuff you're talking about, you're talking about open source design, open
Open source
sourcing of
drones. I
things.
mean, if you
Yeah.
just go to Instructables and
Yeah.
Google open source drone, like you'll find like I found five that looked almost perfect for one made it fully out of PVC pipes. Like
Okay.
that would be fantastic.
Do they have cameras and gimbals and
Yeah, I saw one with the gimbal. Let me pull it up again.
yeah? Why don't you maybe paste that as candidates? So there's flown.
And I'm really thinking we can find a motorized gimbal using servos. So what I think was we'll use the open flexure microscope servo layout and basically remove the flexural components and stick the camera instead of looking down at a slide, stick it looking up out of and there you go. If you make some simple design changes, the open flexure microscope will become a camera on a gimbal.
Yeah.
Yeah,
Okay.
I mean seriously.
Why don't you paste that picture into the? Just talk to me about that. Just show me a diagram of how that you see that happening.
Here we go.
I love it. No, I mean we want to basically stack functions as much as we can. So if you have a flying microscope that turns into topographic mapping, awesome. Uh,
Let's find a better picture.
yeah.
The open flexure microscope already has XYZ servo motor control with a
Oh
gear
yeah.
reduction and a gear reduction. So you can see those two servo motors there.
Okay.
Um, so what the blue piece that's sticking up, I guess I'm not sharing my screen, but like the
Yep.
big blue piece with the logo on it,
Yep.
that's holding the lens, and underneath is the camera looking up.
Mm-hmm.
So basically, if we make some pretty minor changes, we can take this camera, let me see, flip it upside down, and there you go. Put that on the bottom of a drone.
I love it. All right. But it doesn't. I mean, it doesn't have that. Doesn't have that same kind of stabilization mechanism as a gimbal.
So it doesn't have the uh, it does have the center pivot, like center of rotation, like
Hmm.
virtual center of motion mass that it has as a gimbal. But I actually don't think we really need that. We
Hmm.
may, but okay, let me say this. It would be easy to add that in this configuration. We just add an extra gear and we convert. You know, yeah, it would be easy to add a secondary gearing mechanism and move forward with that.
Uh huh.
That's
Do you
trivial.
have is OpenFlexure available on FreeCAD?
Well, the design files are certainly available. I can convert them to FreeCAD files for you if you want to.
Do you have a copy of? Yeah, if you can, just the whole thing in FreeCAD.
Yeah, sure.
Hmm. Cool. Um, what's the? Let me see. What's the canonical documentation for OpenFlexure? What is that? OpenFlexure.cc or
What's your
let's see.
project?
OpenFlexure.
Yeah, here it is. Got the link
OpenFlexure.org.
here in the.
Okay. Um,
Yeah,
yeah, that's
I don't know if you know this. They're taking the. I don't know if this is confirmed, but I saw an article. Someone's planning to take an open flexion microscope up to space
uh huh.
in the upcoming mission or something like that.
Oh yeah. Cool.
I've got about a half dozen open flexion microscopes here, by the way.
Okay. Okay. All right. But you haven't as far as the open drones, you're not concerned about it now. Would the plan be? Well, let's see how we roll this out. But let's think about. So with a drone, the actual processing of the images into the
I think the
top
plan,
hole.
just like the plan with the skid steer,
Mm-hmm.
it's to start with a commercial platform
Mm.
and then build the programming, that is to say, like the order of operations around it, as open source as possible, and then plug and play. We plug in an open source drone into the workflow.
Yeah.
Because we could take on the project of bringing the drone courier drone into a practical design for manufacturing context. I honestly think that's a bridge that we should let someone else. We should hire someone to do that, or we should put out an open call for you know modernized design of a drone courier or practical design for manufacturing.
Mm-hmm. Mm-hmm.
We could take it. We could tackle that challenge, but that could also be a challenge that anyone tackles.
Yeah. Absolutely. Tell me more about the process for an open call.
Oh, sure.
So would you do this like as an little incentive challenge with a like a reward or something?
Yeah. So I don't know. Do you know about Public Invention? Robert Reed in Austin, Texas.
I know about public invention. I haven't talked to the guys ever. Hmm.
Okay, he was my mentor. He brought me into the open source world, and I still do a lot of work with them. They've got a really nicely tuned protocol for onboarding volunteers. Now the rub is almost all the volunteers are full time remote, and their attrition rate is really high. A lot of people drop off. But yeah, I mean, we can get on LinkedIn, get on Instagram. Hey, Open Source Ecology wants you to make design for manufacturing of this. Like, let's make a GitHub repo, open some issues, allow for some competing to, get the best design. Open source is so beautiful. We can do almost 0% of the work if we make it obvious what we're looking for. That's the real work that needs to be
Paste
done.
in the open. Is it called open? What's it called? Open invention.
Public invention.
Oh, sorry.
Public invention. Yeah. So public invention has the volunteer pool that we can recruit from and so forth.
Pubinv.org.
Yeah. Yeah.
What's okay? As far as do you want to talk about that a little more? Like, because I mean, part of the thing is obviously getting people to do this. So probably what we want to do is map out the architecture and see how we can deploy it through various open channels.
Yes.
Mm-hmm.
Yeah. So this is in parallel with this is not the open picture, but this is the drone courier. So we make that note. Okay. Um,
Mm-hmm. I got the yeah.
um,
Mm-hmm. Mm-hmm.
oh, yes, perfect. Yeah, right. So Paul mentioned someone we could tap to help us with the redesign sprint. Obviously Drew and Corey is someone we can talk to.
Mm-hmm.
Right.
Mm-hmm.
But yeah, putting out an open call for design for DFM files. Yeah, I mean that's basically how what the friend of mine that I met who's helping me to, I think, design basically a commercial package of this drone. Is I basically gave him a call for, hey, I would like to see a design for manufacturing on an open source drone for commercial ag tech. And like, all right, shit, I can do that. A lot of folks who are already doing this kind of defense contracting work would be more than happy to gain attribution to design a file.
Yeah, I like it. Mm-hmm. Very cool. Okay. Um, so so the tractor though we need to design. We can't work off existing tractors because you can't really retrofit them for your own solenoids and things like that. So the skid steer.
Yeah, I was thinking, I don't know, what do you think about like a mini skid steer, like a ride-on skid steer?
Yeah, maybe you
Um,
could.
do you think, because what I was thinking is if you have, I know they can be used for grading. I know they're much less powerful, but I do know that the cost is like 5 to 10 times less to buy a commercial mini skid steer, riding skid steer. Like
Yeah, but
you
if
can
you
buy one for like 2, 3, 4, 5K. Yeah.
well, so if you get one off the shelf, I mean that's going to be a pain to just try to retrofit everything. You have no control over any geometry, so I wouldn't do that. I would just build from scratch. So we could decide to build a larger or smaller one from scratch. I mean, we could do the easiest way to do it is just do a simple, super simple cubic platform. Just put wheels on it with hydraulic motors. We just work out all the controls just on a little demo bed, right?
Yes. Yes. Yeah.
Or even
I think.
yeah.
Go
I
ahead.
mean, if
Yeah,
you talk
you're exactly
about
right.
if you talk about solenoid control, you can even go with, well, you're just turning on a solenoid for an electric motor. It doesn't matter if the hydraulics are there as long as the controls are identical, right? So all you're doing is just turning on actuating a direction forward or backwards on each motor. Mm-hmm.
Right. Right. Yeah, I think you're exactly right. Um, my thinking for wanting to kind of preset a smaller form factor
Mm-hmm.
is to kind of embrace a swarm robotics design ethos, so that it's like from the very beginning we always expected more than one like skid unit to be present when we're doing these operations. So that my thinking is, if we're going to embrace autonomy, the reason people already don't use swarm robots is because one person can only drive one skid steer. But if we release that constraint, then it kind of lends itself to mini modular robots working in a collaborative way.
Oh wow. Yeah, absolutely, absolutely. Now, are you aiming? I mean, first in sequencing, you want to do one first and then do a swarm. But yes, we're setting ourselves up for the bigger swarm immediately. So we should
Yeah.
do, man.
Yeah.
I'm thinking about the schedule for this. Maybe we should, if we've got your expertise on board, maybe we should do it not because we're looking at May 1st as this is the basically 3D printing. So in 3D printing, it would actually include things like we're 3D printing rubber wheels because wheels are actually a big cost. Like the rubber just it lasts like a year or two, and you got to spend like $1,000 again. Like each wheel is like $350 for the rubber, just the rubber itself. So 3D print. So we were talking 3D printing as some of the first things to reduce the cost of the house, but maybe we should be going right into the skid steers because if we've got the expertise from you and we've got energy around, I know that's a very sexy thing because
Yeah.
I mean it's low hanging fruit because
Yep.
the mechanical stuff you can easily do, and then to upgrade from regular to RTK GPS. Now that's the art of modern electronics, and we've got that covered with you, right? And the
Right.
GPS
Right.
modules. So maybe we should just front load that right into May, like May 1st. We do a little swarm, or maybe
Yes.
let's see what we can do for. And I would go like that, where think about May as the target that prototyping, and before that, of course, prototype some. But the important thing would be to generate the curriculum modules and things like that for that, right?
Yes.
And so, how much of this is documented at present? Do you have anything, or we don't have anything at this point? Mm-hmm.
No, I've got nothing. Aside from the the software package that I showed you,
Mm-hmm.
which again I'm trying to commercialize that, so it makes sense to spend some time on that. But I mean, to your point,
when you say commercialize open source, right?
Yeah, open source, yeah.
Of course, but commercialize, yeah, that's good. So you have
I know. I say commercial, and people are kind of like, "Wait a minute."
Yeah, right. Just to clarify for the audience.
And I think people are. I think that's so. I don't want to sound too gimmicky, but what it is a software as a service, right? It's cloud-based, farm robotics and farm imaging data analysis, platform.
Mm-hmm.
But the open source software as a service with a centralized server space, which is like basically that's your moat, that's your economic advantages. You establish the digital infrastructure that it's too costly to replicate quickly, and anybody willing to replicate it would also have to catch up to your software, and you're already advancing by the time they catch up. Like that's how OpenAI was supposed to work. Of course, they have their own issues, but
Well, that's the core of the open source model. It's based on innovation. You do your stuff, you publish it, other people catch up. You're always ahead because your business model is innovation, not paywalls, right?
Yes. Yeah. So that's what's going on there. But I don't have any design already done for you. Actually, I've got things that I've been teaching the students with. It's a toy, closed source, but it's a skid steer, right? It's used Mecanum wheels, so it has a skid steer functionality.
Okay, can we use that as you put like back and forth control on it? What's it got for the controllers on the wheels right now? Is it like all four wheels independent?
It's got a commercial package, but I could easily, I don't know if you can tell, I could easily replace it with like a Raspberry Pi or something right in there.
And the motors are what? What kind of motors?
Motors are, the dual DC motor. I can't quite get the camera on it, I bet. Mm-hmm. I should go on my video chat even up.
Yeah. Yeah, I see you there.
Yeah, here we go.
So those
motors right there.
And permanent magnet DC?
Yes.
So they're getting ESC signals?
Yes.
Okay.
So I could buy a dozen of those and simulate our program on a small scale, or we can shift to, designing a mini skid steer in CAD and just do that, the industrial design workflow.
To parallel it, develop it right on that. But how are you going to do so if we assume hydraulics with simple on and off solenoids, how would you simulate that in that robot? Is there a way to control the ESC such that just voltage on one pin is forward, voltage on another is backwards? I mean, that's how it works, right?
Yeah, you have to use an ADC, analog to digital converter. But sure, yeah, that would be fine. I don't think I wouldn't worry about it because the control on that level is so easy to switch from digital to analog. It's trivial.
Okay. Mm-hmm. Yeah. And then, so let's going back to the design there. So let's start fleshing this out. So what's the controller look like? Let's start adding more stuff to this. So we got controller, skid steer or rover, whatever skids. It could be your little rover. That's fine. So start fleshing out. What else we got there? So we got the 4 solenoids for the 4 independent wheels. Bidirectional.
So I know y'all have a power module. I can't remember exactly what the
So power cube.
Dig too deeply into it. Power cube. That's right.
So
if that's the idea, then we can. if we want, if that's the direction you want to go with that, then we can do
Yeah,
that.
yeah, absolutely. That's proven tech. That's a modular power, completely modular power unit. You can use it. You can use multiple of those. So scaling is completely addressed with this. Mm-hmm.
Perfect. All right, power cube as an engine. Um, and then from there, there'll be a transmission design.
Well, the
And
transmission
here,
is yeah, yeah. I mean, there's right now we're planning on, so that would be chain drive, direct chain to the shafts. So if you use very cheap hydraulic motors, just using simple chain, like a 100 weight chain, gets you the high. Add the skid steer level. That's where you get the kind of torque you need. Using very inexpensive hydraulic motors that cost only like $150 each. So we're not talking about like a $10,000 hydraulic motor. We're talking about a $150 hydraulic motor.
perfect. Yeah, that's great. Okay, that makes a lot of sense. Um, what do you think? And you say we're going to 3D print the wheels and
Yeah,
the
so
the
let's 3D printed wheels. We've got
and what you do the torch table for the
yep,
body.
mm-hmm, yep.
Okay, and I assume like fasteners and stuff.
And then
Like on the mechanical,
I just talked to.
we'll just need.
Okay, go ahead.
Yeah, go ahead.
Mhm.
No, I'm sorry. Go ahead.
I talked to Peter Haas just recently, and let me see. We were talking about. So he's into robotics. He's actually another TED fellow I know, and we're talking about open source robotic arms. So actually, like with the frames, yes, one is that's torch table cutting, but it starts to get funky with our universal fabrication scheme when we're talking about WAM, wire arc additive manufacturing. So you can 3D print in metal the whole frame. So that's, I mean, if Peter Haas, if Peter comes forward with that, if that's available, I mean, we can put that right into April, May, the May build ideally. Mm-hmm.
Right. Perfect. Okay. Yeah. You
Yeah,
think?
so
Yeah.
crazy,
Okay. That's perfect.
crazy stuff. So we definitely got 3D printed wheels. We've got, um, okay. So what's the controller board? So let's talk about what are we doing before you go to there. How did you process your images, 30 images into the 3D terrain?
There's a um there's a software called Node ODM. Node ODM is the open drone mapping software developed by some other folks.
Mm-hmm. Mm-hmm. Okay.
So there's a package you can feed your data into. It will sketch the images together and
Mm-hmm.
infer the uh, the depth and uh, 3D geometry of the shapes.
Cool. And that's straightforward. It's like you download the software, you feed it the data, and it outputs a file for you, a 3D topo file,
Yes,
or
my
how?
yeah, my thinking is because you want some, like you said, you want some computing architecture behind that.
Yeah.
Is that something that can be done by my server design?
Yep.
And of course, I'll free license or anything like that. But um, so my thinking is you
Yep.
take your images, process them on the website, develop your travel plan for your robots, and then what would be ideal is if the robots have Wi-Fi, they can also communicate to the server and receive updates in real time. Otherwise, they can execute a pre-planned pattern with like basic error correction.
Mm-hmm. Okay. What's the format of your topo file? What's the file format?
So they're usually, I think they're called STYs. Um, I think that's the name of the file type.
STY? Is it just like a point map or
Yeah, like a mesh, like a 3D mesh.
STY 3D mesh? Mm-hmm. Oh, you're talking STL or
Not STLs. Let me check really
STY
quick. Let me go
doesn't
back and
seem to
check.
be. It's not a 3D format. Oh, STY. No, STY.
PLY. I'm sorry, PLY.
Okay.
Yeah, PLY. That was the name of it.
PLY.
Yeah, it's a
Okay.
Polygon file. Yeah, yeah,
Okay.
it could
Okay.
easily be
Polygon.
rendered as HTML. Yeah, yeah. Yeah, Polygon 3D mesh. Yeah.
Okay. Okay. Let's talk about controller. So, what are you thinking for the controller? Are you into any Beagle capes? Peter was talking about actually Beagle capes. He's super concerned about security. He said that shouldn't be an afterthought.
Beagle board.
Yeah. He's
Oh
into
yeah.
Beagle
Well,
capes, but what are you thinking?
yeah, that's fair. You know, on some level, at no time in commercial history, whatever, like consumer market, have has anyone had an autonomous heavy duty robot in their property. So this is brand new. We're breaking new ground in the security world. Like never have you had an autonomous vehicle that could kill you and destroy your house
Mm-hmm.
outside of like the iRobot movie.
Mm-hmm.
So yeah, I mean that's a fair question. I don't know the answer to that. Of like how do you secure a self-driving skid steer? Probably the same way they secure Roomba vacuums, which is not at all. China is just going to look in and see. Um, so yeah, I don't know the answer to that question.
Yeah, but I think like if you're just running a local network, that is safe unless somebody's on site sniffing you. So if it's like say you
Yeah,
do remote control, but you're on site through LAN, then that would be one way to address that. So you're
yeah,
not
yeah,
vulnerable to global attacks. Yeah.
yeah. I mean, there's always going to be a concern, and we should probably talk to folks who have the expertise in that domain. But yeah, I mean, yeah,
Yeah.
basically isolating yourself from the larger network. Um, my thinking is you want to open yourself up to the network to get. I'm shamelessly plugging of my net-based model to get updates from that. But sure, I mean, there's no world in which you couldn't put a radio receiver on there, connect it to a Raspberry Pi, use it, locally control it.
Mm-hmm.
If you're talking about real-time updates and computation on a local network, you're going to have all your local, you're going to have all your compute local as well. So that puts you into the GPU space, and then that gets a little hairy. But yeah,
Mm-hmm. Now the other thing is just a remote, like a handheld remote controller option as well that feeds into the
yeah,
same.
yeah.
So, okay, so go ahead, keep fleshing this out.
Yeah. Yeah, and I think talking about some of this stuff is a very new domain. Thinking in terms of safety, like for example, if you're in a self-driving car, if you take your hands off the wheel, it's going to get mad at you. It's going to turn the self-driving off.
Hmm.
Probably we should have the same control for a skid steer, maybe even more so. You have to hold the controller. If you don't hold the controller, it's not going to drive. You know, um, so I would consider adding some constraints like that. And so I think we should do the handheld no matter what. You know,
Mm-hmm.
but yeah, you're talking about bigger board. I mean,
When you say
the stuff we're
algorithmic, you're
talking
talking
here.
about AI control,
No, I'm
self-driving.
just talking about like for example, like the pick and place machine. It uses an algorithm to determine the optimal path. It's a local non-AI
Mm-hmm.
analytical model, optimization model. That's what I'm talking about. So, for example, if I tell it, "Hey, move my chickens from this paddock to this paddock," or give it a schedule for moving my chickens, then the algorithm should determine what control paths my vehicle should take to reduce wear on the vehicle, to reduce fuel costs, to reduce the distance and time. Uh, so like the path planning, yeah, should be done automatically, algorithmically.
Mm-hmm.
Yeah, Raspberry Pi would get us most of the way here. I'm thinking there may be some world in which we want a PLC. Um, we definitely gonna want some high
How do you
ADC
get the arrow
voltage.
in the dock?
So how do say that again?
You do the arrows, back arrows. How do you get that on a keyboard?
Oh, yeah. So you do the less than symbol dash dash greater than symbol. That'll get you the two-way arrow,
Oh, I see.
and put a space. When you do, once you're done typing, put a space. Oh, I'm sorry. More like
That. Oh,
yeah,
that. Oh, yeah.
yeah. We yeah. Yeah. Let me look at it. I mean, the reason I don't want to commit to you and say, oh, let's use Raspberry Pi, let's use a Beagle board, let's use an Arduino, is because I've only developed them for research. To develop a logic board for to use in the field, in a farm, literally in a field, um, maybe there's a more robust option. I just have to research and find if there's like a really if there's a first of all if there's a waterproof board, that would be the perfect thing, you know. Um, so let me do a little research and figure what's the best board to use. But we're into Raspberry Pi land. You know, nothing too scary
Mm-hmm.
coming down there.
Is Raspberry Pi land? That's above the Arduino Due, 32-bit, right? That's the next level up.
Oh, let's see. Due? I haven't heard of that one.
Uh,
Oh, you're talking about Duo, right? Oh, Due. Yeah, I haven't seen this one.
is that also similar power, or that's way less? It's
It looks like it's using a 12-volt barrel jack, which means it's probably on the same order.
it's 84 megahertz. No, that's I mean the Raspberry Pi is way more than that.
Okay.
All right. I mean Pi is we're talking about gig, or what's Raspberry Pi clock speed?
I'm sorry, say that again.
What's the Raspberry Pi clock speed?
What is it? What did it cost?
Clock speed. So 2.4
Clock speed.
gigahertz.
Oh,
Yeah. Okay. No,
I
that's
think it depends on which logic board is on there. So they've got this new one, the um, RP 2040, RP 2050, 2350. So there are a couple of different boards. But yeah, I'm not sure about the clock speed. That's a good question.
yeah. Some of the other ones were like 2 gigahertz. Well, no, this one is 150 megahertz. All different ones.
I'm less concerned about the logic level power. I'm more concerned about we were going to need a pretty heavy duty battery on there or power supply, and the Raspberry Pi will communicate with a um, uh, current amplifier or a voltage amplifier, and then that will draw power from our supply to drive the solenoids or something like that, right?
Mm-hmm.
So yeah. Converter slash amplifier drives the solenoids and the actuators. I'm trying to think of the role of the engine then. So we might be talking about a hybrid.
So the engine is just a gasoline engine, and yes, it's a hybrid thing where there's a regular engine running a hydraulic pump. So you're doing
Yeah.
fluid power, which is very flexible, so allows you the modularity and easy transmission. It's transmission-less
Yeah.
in some way.
I think your solenoids, I guess, are going to be driven by heavy duty DC power.
Solenoids are, yeah, so let's look at some of the solenoid valves. Like in the first prototype, we do like a 12 volt DC, 10 gallon per minute kind of a thing. 2000, let's say 3000 psi. Yeah, each solenoid like that is like $100 or $200. These kinds of things. Well, let's see. Let's go to surplus.
So I found an open source speed controller here for engines.
What kind of speed controller?
It's open ECU. I've got a link to the open electronic control unit. So this is for controlling engines.
Oh well.
I got to investigate how open they really are, but
Right. Right. More interest is like electronic fuel injection. There are open source projects for that. So once we're building these things, you can do, by doing that electronically, you avoid all the complex timing things or complex carburetors. So, and replace it by
you're going to know a little more about that than me.
yeah, so electronic fuel injection is the state of art of what you get for modern electronic controlled fuel efficient engines. So instead of using a carburetor, you use fuel injection that's timed by electronic control.
Right, sure.
Yeah, and that's
Like
so
large engine
that's like
versus
the
small engine.
that's the next step above this. I'm not sure we need to. We're not really there yet, but. could get cheap ones, like $100 or so.
Oh.
Yes. Let's see, let's do.
I see you're on the first slide. If you also want to check the second slide, that's got an additional breakdown of the control design.
Mm-hmm. So gas engine, just simple gas engine, drives, hydraulic pump. Are we? Sorry, are you talking about? So you're talking about the kind of prototype you want to do? That's what you're saying?
No, I mean, we could do it. I think this is also a question. I'm not 100% sure. So what you're
Yeah.
saying
So it's
is
different paths. So
the engine will always be on. Go
yeah,
ahead.
yeah. You can
The
control its
engine always
throttle.
on, driving the hydraulic pump,
Yep.
and then the solenoid just tells it when it should be transmitting
Yeah.
motion. Right.
Yep.
Okay.
Yep.
So then this isn't needed then. Just a
Yep.
hydraulic. Right.
Drives hydraulic actuators.
Yeah. Perfect. Perfect. Yeah. So I've underlined that because I need to do some research and find there may be already an open source product for that needs to supply an amplifier for. So I actually did like 12-volt solenoid control for my hand exoskeleton project for a PhD. So I had a hand exoskeleton pneumatically driven, controlled with solenoid on a 12-volt circuit. Um, but for maybe a 12-volt circuit would still work, but for the kind of cracking pressures and stuff that we're dealing with, there should be kind of unique
You
design
still
choices that I'm
have
not familiar with.
no. You're still talking about 12 volts because that's going to be the 12-volt battery on a on a skid steer, just one battery. So yeah, they make
Right.
those like the things I linked to. Those are 12 volts, and they do like 3,000 psi. So
Oh,
high
perfect.
pressure, like those things they put there. Take a look at those. They're on a slide
Yeah,
one.
I'm looking at yeah.
Mm-hmm. Ones like that.
Nice. All right.
Do it. Mm-hmm.
Obviously, a stick back to the gimbal really. I really think a I really think a two DOF or like a DOF gimbal is going to be more than enough. Because yeah, the gimbal, the nice thing is all your other degrees of freedom of the gimbal are provided by the drone movement. So you don't need the gimbal to have really all that many
Right.
degrees of freedom.
Mm-hmm.
Yeah, this is great. So do you already have CAD for the chain, like a hydraulic motor and a chain driven mechanism, or is that something that we need?
We do have some of I mean, it's not adapted for this. We have things like, let's see, Universal UTU. Let's see what we got here. We got some. This is nah. It's actually track unit, chain drive. Nah. Let's see. Let's see chain drive. Not really. This is something perfect for like parametric CAD generation or even schema. So the latest thing is on FreeCAD that I've been doing is create a schema that defines parameters for something. Then AI can get you a compiler, and then you get geometry into FreeCAD. So you get this compiler actually gets you. So this is really cool workflows. Like we can really leverage that. So I'm trying to actually document that because I mean, we're going to start using that left and right. I think that's how we're
Mhm.
going to solve the full automation of the CAD automation, so we can get blueprints
Right,
for new house models in a matter of hours for
right.
a whole new
Okay,
house,
good deal.
including the design, new design. Crazy.
Yeah, I mean, what you're talking about sounds like something I'd love to integrate into the ground control to, use AI to generate um,
Hmm.
like model paths and other things like, yeah,
Oh yeah, then you can
that's
talk
cool.
about yeah, because you can use dedicated packages, or you can just tell AI, no, just give it to me directly, just figure it out.
Right,
That's your universal computing engine then. Yeah.
right. Cool.
Yeah.
Okay.
Okay. So we've got some notes here. I should get going soon, but what are our next steps? Oh, look at that. Yeah. Oh, nice one. We're yeah. We need to generate all that kind of stuff. Uh huh.
Cool. Okay. Yeah, I'll look at that. So yeah, I got two tracks in my mind. Should I make a miniature version of this system where I can actually prove it,
Prove it.
or should I stay in design land because I just don't have the finances to build a prototype yet on my own? Um, so that's what I'm thinking is what is going to be the most helpful thing for me to do right away in the next few weeks? It sounds like yeah, like start with some CAD environment rendering of these subsystems like the chain drive, and then prove it. Maybe 3D print some basic models.
How about, I mean,
And
if you
I
have
probably
that,
can.
I mean, if you have that rover already, then you
Yeah,
also have the RTK GPS. Do you have a controller? Like, do you have money or resources? So you got controllers around? You probably got
yeah, I've got a
controllers.
controller for this, and yeah, I've got plenty
So
of Raspberry Pis.
so why not do a system like int? Do you have any joysticks?
Yes.
Why don't you do a joystick controller? That's one side, but the other thing is, of course, the RTK GPS. Start on a. Both are needed. I mean, the joystick is useful in that you can just get ready control like in a second, right?
Yeah.
Can you do that? Maybe prioritize the joystick and then just do the RTK GPS system. So what does, I mean, just briefly in a minute or two, what does that system take? You've got the base station. What all do you need to do? You need a RPi with what?
So yeah, I mean this already has pretty much everything I need. It's got the speed controller in there, and it's got the battery chambers. All I need to do is I put the Raspberry Pi on my joystick, and so the Raspberry Pi will do its own onboard computation while receiving joystick commands and use the same radio frequency communication that was already established. Basically piggyback off of the remote control to off of the joystick to do the control for the machine.
So is the joystick, that's a dumb thing. That's just touching contacts, right? So you put
Yeah.
an RPi on it, and upon receiving those signals, the RPi gets you signals to the rover. That's just just direct remote control, right?
When you say rover, you're not talking about GPS rover. You're talking about this little machine I've got here.
Yeah,
Is
that.
that right?
So
Yeah.
we're saying here's the joystick. Now, how do we do that and actually incorporate you got tool paths, to mission planning. How do you get that connected to RTK GPS? Because that's going to be the beautiful part. Hmm.
Right.
So how
Right.
can you go walk me through that real quick? Just what's the concept there? What are the components? What's or
Sure. So, uh, if you give me just a second, I know I'm keeping you over, but
mhm.
let me see. Probably got the controller sitting somewhere here. I'll keep looking for it. But basically, I've got a joystick that does the control for that receives user input for the rover. I'm going to add a Raspberry Pi to that, so let me put that. Okay, yeah, here we go. Joystick. I'm going to add a Pi. Well, I'll do a table for.
And for the joysticks, are those things like, as we rolling this thing out, that's something we get right off the shelf, or do we just 3D print that and make a simple one? Or
Yeah, easy, simple, nothing too complicated. Yeah. We
but
should probably just
buy it off
order
the
it open
shelf,
source.
just get it off the shelf, or no, or just make it.
I bet we can do it off the shelf from an open source vendor like Crowd Supply or something. I'm sure they've got one.
Okay.
We could find that. Yeah.
Okay.
Yeah. Yeah, this will be fun. Because even this mock-up that I've got with this, if we can make an open source version of this could be useful for chickens, for going around to pick up chickens or keep them in, uh, this is a funny story. I visited a farmer, last weekend, an older guy, and he had a flock of goats, and he was trying to herd them into a parcel. And like the two of us, we couldn't do it. Like they were just too fast and too many of them, and they kept running away. And I was like, if we had a drone or even a rover on the ground, like to help us and just like scare the goats and put them in the pen, like we would be done with this so quickly.
Yeah. 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 Um, okay. Can you flesh out? So you've got the GPS, the thing that Nathan showed us.
Yeah,
How does that connect? Can you do like a little diagram of what connects to what?
sure. Are we in? We're here. Okay, sure. Okay.
Mm-hmm.
So yeah, I guess I really should be using your formula here. Oh, all right. Does this look right to you?
So what's the board and what's the controller?
Yeah, right. So that's what I was. So the board will be our Raspberry Pi. The controller will be our path planning algorithm. Yeah.
Right. So you got the facet connecting to the RPi, path planning, rover. Okay, but do this. I want this. As well. Can the same joystick do that?
Yeah,
Yeah,
I think we're talking about the same thing. Yeah.
right. Because I mean, but you want to do. Okay, so maybe not. I mean, I want a joystick where if your RPi just doesn't power up, you still can run the rover independently. So
Sure.
you do the joystick, then the rover has to have the communications, the receiver for the solenoid. So that would be. I mean, hopefully we can make it the same components for the. Well, we just have to think about it with the details of how that looks.
Yeah.
But we want to have the
We'll
joystick
figure this.
independent of the rover, of the Pi. Yeah, yeah. Okay, so that's a high-level diagram here. We've got now the detail between Pi and Facet. So you're on top of that. I mean, you done that already?
Yeah.
Or?
I've
Okay.
done it with the like web server stuff for my ground control, but I haven't done it with a microcontroller. But it shouldn't be hard. Yeah.
Well, because right, right. So there's a Wi-Fi connection between path planning and the RPi that's live, or no, or is the RPi independent?
I'm
What?
building the live online version, but more likely for the demo because I'll do that in parallel with my commercial development. Will be local.
Okay. So which of these do we want to maybe see what we can actually prototype? So a thing where you've got the facet and the RPi, and you're actually showing that what's a good proof point. We're saying we're gonna mission plan this
I'm
to
gonna
go from
I'll
point
dump
A
a
to
bunch of
point
dirt on
B.
the ground and grade it.
Yeah. Um, what's realistic for like with the rover? Like, would you actually be replacing? Can you actually try to modify that to make it work? Like you're actually testing
Yeah,
the system?
sure.
Okay.
Yeah, I'll put the arm down. I don't want to backdrive it.
Mm-hmm.
Yeah, I'll put this arm down. I'll go from there.
Yeah. Yeah. So there's a few steps there, but
Yeah.
and if you can do that, if we have now, let's see the. So are you actually going to get little solenoid? Are you going to simulate to the point of just getting a solenoid relay, or no? Not that detail.
Let me wait for that. Yeah, I'll wait for that because I think it will be a self-contained trivial challenge.
Okay.
Like it would be like I don't know. Yeah, let me
Yeah.
wait on it. I mean, I think let me make the demo, and if you think, oh, this is not realistic because it's not a solenoid, then we'll do that instead.
Okay. When do you think you can do that? By?
Okay, give me a few weeks. Yeah, give me a few weeks. I'll get that done.
Okay. Okay. And that at that point we can say, oh, look, we've got. So what's the goal there? Where you're talking about mission planning, and you're actually driving this thing from point A to point B. So that's right.
Mission planning. The framework is functional.
Mm-hmm.
There's no, seizing points. Like if we can say, hey, the facet, the joystick, the RPI, and the path planning work. All we need is a high power rover. That's the only difference. The only difference is a
Yeah.
solenoid and a
Yeah.
high,
That's all.
high power system. Then you're done.
Yeah. That's. I mean, if you show that, then we can put it on a on a real
Yeah.
machine. Now, tell me
Yeah.
about the just immediately what you're seeing. You think you can do the joystick, which is just direct remote control without Pi? Can you do that too, or no?
Yeah, I'll do that without the pi. Yeah, because you got to think the
Because
basically basically the joystick has to have its own pi or its own internal you know Bluetooth controller to drive the rover. So you're talking about essentially like two Raspberry Pis or one pre-built controller and a Raspberry Pi.
okay,
Um,
check this
you
out.
know,
What I'm getting at is, so say we got in a real system, we got solenoid drivers, solenoid relays, and solenoids. Can that
yeah,
relay, obviously, you can connect to Pi, and you can drive that. Can you also drive that with simply another RF source, like your joystick? So the joystick's got its own little battery in it. You're sending a signal to the solenoid, and that solenoid is being activated. So can you design a system where the solenoid is being activated either by lone joystick or the Pi? In other words, if the Pi is turned off, the joystick still works.
sure, yeah. And you're imagining that the pi in this scenario will be fixed to the machine,
Yeah,
right?
I
Yeah,
think so.
sure, that's fine.
Hmm.
To be honest, I was thinking the pi would be in the handheld also. So all the computation
Um,
happening really. Well, no, that doesn't make any sense. No, I'm wrong. I'm wrong.
well, okay,
Okay, no,
okay.
you're right.
Now the next layer of complexity is if you put a camera on this thing and on your joystick.
Yeah,
So you've got like one of the drone controllers. You got the joystick and you're looking at your field of view. That is the
right.
juicy thing, because then you can really be talking about, okay, I'm inside a building, I'm looking around the corner, and I'm controlling that. So you got to have a camera.
Yeah, right.
Is that in this iteration or a
Yeah,
further one? Do you have? Is that easy to do right now or no?
yeah. I mean,
Uh, uh,
I've got. Yeah, we'll do that in this iteration, but it'll be offline computation. So what I mean is, I'll do a drone flyover, or I'll take a pre-video, and maybe it won't even be a drone. It'll just be my cell
mm-hmm,
phone camera video,
mm-hmm.
and then I'll use that data offline to compute the path.
Okay. Yeah. Now it would be interesting now to think about curriculum. We have a simple controller. We write a little app to use our cell phone, right?
Sure,
That's, I mean, that
absolutely.
would be such a powerful thing. So hey, we're doing some programming using our cell phone to do remote control, and we're doing remote control of real live machines,
Yes.
all in one day, while we build a tractor with remote
Mhm.
fabrication in the other room.
Because like you said, yeah, I mean, we're talking about integrating, like, my PhD was on this, and I was actually a PA for this class for a long time called Applied Mechatronics.
Yeah.
And that's what we're bringing is agriculture, agronomy, ecology, plus applied mechatronics so that you can solve problems, not just notice or identify the problems.
Yeah. Wow, it sounds like you're a rocket scientist, man.
I learned from the best.
Awesome. Okay, well, that sounds good. Yeah, let's do this. I mean, if you do this little prototype, I mean, yeah, we can completely translate that to the skid steer and think about starting to design that. So, yeah, I mean, I think maybe we should just go for May 1, as we're gonna actually start doing this for real, and get the torch table out by that time and cut some steel and make that thing.
Yes.
Oh,
Yeah.
actually, I have. We built a. If you want to do a pretest, we already have a four-wheel platform which we built during the Summer of Extreme Design build. That was 21. Have you seen any of that by any chance? But we have a rover,
Well,
like a 2,000. It weighs about 2,000 pounds, and it's got four big wheels, and it's ready for hydraulic motor. It's got two hydraulic motors on it now with chain. So if you want to actually test well, we can easily add two more motors to it. But we already have a life-size kind of tractor platform that we
is it
can
the
like
track life, track life
life life
device that
track.
you're talking about?
Oh, and as far
Live
as
track.
that, I mean, that's that thing. I busted some of the hydraulic. I'm riding on two-wheel drive right now with that thing, so we
Mm,
don't really have it. But we can put it. Oh, we've got a working micro track, but that's only two, that's got one motor on each side. So maybe we could
mm,
actually add it to that. That thing works.
yeah.
We can make that.
Whatever you want to do. Yeah,
Yeah,
that sounds
whichever.
great.
Oh yeah, so maybe the micro track. So think about it as because that's similar to a skid steer drive. Like in the next build, I actually wanted to have four independent motors, but simply by putting the two sides in series, you've got effectively just two motors that you're controlling. So we can do
Hmm.
that and do that first test on a micro track, for example. Yeah.
Yeah.
Okay. Yeah. Okay. So from your device, we're going to micro track. All right.
Yep.
Cool. Have to fire that thing up, get it out of the metal piles. Yeah. Okay.
You've got some chores too.
Yeah. 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 Okay. Well, this is great. So yeah, let's keep going and let's keep in touch. When should we meet next? Do you want
Let's
to
do
a couple of weeks
does
or?
next Friday work? That'll give me some time to flesh this out.
Okay. You
Or we
want
can do next Wednesday.
to? Okay. So continue fleshing out these details, or do you want to just get busy on actually implementing it? I mean, we got to
Oh, I
document
can do both.
and implement. I mean, we should maybe like meet next. You want to go next Wednesday and just continue just fleshing out the details in these diagrams? Yeah.
Yes.
Okay.
Yeah.
Let's do that. I'll send you an invite. Same time work for you?
Yes.
Okay. Well, I'll see you next time, next Wednesday then.
All right. Sounds good. I'm making
Thanks.
a roboticist out of you. We're gonna do it.
All right. All
All
right.
right.
Awesome. Thank you. Bye bye.
Okay.
Yeah.
Bye.